Okay, next we are moving to methods, the M. Before I forget to mention it, one thing I forgot to talk about in the introduction section is that typically you would have to address ethical concerns if you're working with humans. So the ethical concerns would go in the introduction. So, for example, if I'm working with prisoners, I would have to get specific permission, not just from the prison, but probably from the state of California to do these kinds of experiments, right? Because when you're involving human beings, for example, like if you're working with kids, right, you have to get ethical waivers from that. When I was doing my other grant project last fall, just to try to help out the UB students in the Bahamian community, I had to get permission from the ethics board at UB just to have the classes at all. We had a little questionnaire that we gave the students and people after the events, and then we had a follow-up questionnaire. Each of those documents, because we were dealing with UB students, had to be also cleared by the ethics board. So these are things that, depending on your field, right, you would have to make sure that you're covering because you can get in. I mean, probably not. You're not going to get arrested, but it can invalidate the study. It can invalidate the research, and it could invalidate your job, right, if you're not covering the ethics of the research you're doing. So I just wanted to mention that really quick before I go into this discussion. Okay, methods. Now, basically, the methods are outlining the materials you used, right? What did you do? Where were you? And the procedures you followed to execute the study and to analyze the data. Okay, this is a general overview of what the methods are trying to do. Okay, if you go and read any science paper, they're going to tell you, the equipment they use. Like, for example, if we're doing, particle physics or something, they're going to tell you the equipment they used, probably the location, the lab, people involved, what procedures they were using, what materials. Not here. I mean, like if they're doing, an analysis of gold or something, they would talk about using gold, and then they crunched all the numbers in a computer, blah, 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 to result in this. Okay, so you just talk about all your materials and equipment here. There are some tricky bits to the methods. Now, there's no specific way to do the methodology section because there's no, agreed upon structure for the organization. Also, the level of detail that you put into the methods, there's no real rule about that. You don't want to be too detailed because then it's unnecessary. Each of our scientists wore a suit and tie to work. We all had bologna sandwich. You're not going to list the day-to-day quotidian stuff. Okay, so clearly that's just goofy. But sometimes you'll read these papers and there's way too much detail, and you just think, why do I need to know all of this? Okay, so there's no real strong agreement on organization. Level of detail is kind of up to you, depending on what you think is important for the paper. Another thing is to avoid self-plagiarism, because very often if you're doing, like, let's say you do a survey, right? And you survey, I think you have to usually have about 1,000 people before it's demographically valid. Okay, if you're sampling a demographic of about 1,000 people, so long as it's split male female, typically you're going to get a pretty good representation of the overall demographics. So let's say you do 1,000 people and you are doing research project alpha. Okay, you have all your research, all your methods, conclusions, but you also realize that this survey could be used in a completely different research project. Now, here, what it means to avoid self-plagiarism, you can keep this survey, right? Using the same survey for different research projects is not plagiarism, but in discussing, for example, the methods of how you got that survey, right? You would have to be careful to not simply like cut and paste your methods from paper to paper, because that's self-plagiarism. So what this means is you can't just kind of copy and paste or borrow the language directly from research paper to research paper. Rather, you would have to kind of rewrite the methods in such a way that they're dissimilar enough to avoid self-plagiarism. This is something that's actually tricky, because even in the humanities, when I'm doing papers, very often the paper topics will overlap quite a bit, even though I'm talking about completely different things. So there might be some methodological overlap. So I have to constantly be careful in what I'm writing to avoid that as well. One thing you want to do in the organization level, at the organizational level of the methods section, is to avoid chronological explanations usually. Okay, it can feel kind of clunky in a methods section because, like I said, you're not telling a story so much as trying to give the reader all the details of the experiment and research that you've done. So a chronological explanation can sometimes feel a little bit clunky. And like I said, since you're not telling an anecdote, you want to minimize the I in research and your projects. Okay. That means, limiting, we and I as much as you can in your science papers. So you want to avoid sentences such as, we were like totally shocked to find that, right? This is clearly a joke, but you want to try to watch out for this kind of language, especially in the natural sciences. Social sciences are a little bit looser, a little bit with these pronouns, but in general, right, we're going to try to watch out for them. So watch out for chronological explanations and try to minimize the use of personal pronouns in papers. So a possible and useful structure for the methods section would be this: background, experiments, observations, and then the analysis. Okay, what's the background? What did you do in setting up the method, the experiment? What were the experiments and observations that you made? What was the analysis? Okay, and how did you do the analysis? Okay, so that's a pretty easy way of thinking about the methods. If I were going to suggest one model, this would probably catch most of your possible science papers. Okay, it's not going to perfectly fit for every single example, but this will fit a lot of them. Okay, so for my sociopathy paper, I would talk about the tests that I worked up, right? The reading test, the comprehension tests. I would talk about the location, the penal system in a certain city in California, where I was going to do the experiment, and my background, perhaps a little bit of my background. Now, this is something, like I said, you want to avoid a lot of I, but in demonstrating your authority in a certain field, it can lend credibility to the research project itself. In student papers, you're probably not going to emphasize this too much, but once you've gotten your bachelor's degree, right, that establishes some of your credentials, right? If you go on, you guys would get a Master of Science, most of you, or a PhD or an MD, whatever. You see, those establish levels of credibility, right? But they also show, you've done a lot more studying and research and writing. So you see that the background is simply, what'd you come up, how'd you set it up, where did you do it, right? Who are you? Who's your team? If you feel that's important, sometimes this can be left out. And then the experiments, right? Then the observations. So we would discuss the implementation of these diagnostic tests on individuals who scored high on the psychopathy checklist. And then the fMRI results and observations, okay, would then be listed. And then the analysis of those observations. So the study found that individuals who scored high on the PCL had a 75% lower irony and humor comprehension than, now here I would have to set up obviously a control group. Now controls in scientific experiments, I'm sure you've probably talked about these before, but a control group is really crucial in most scientific projects because if I have, let's say, demographic X, and I want to, like, let's say these are our sociopaths, okay? I would have to then have a control group who aren't sociopaths, okay? So maybe I would do my control group with other inmates who don't score high on the test, and then just normal citizens, okay? So that way, if these people show a 75% less comprehension of irony and humor than this group, that indicates that I'm onto something, okay? If both of these groups show pretty much, if they're pretty much the same, right? Well, what that shows me in my analysis is that irony and, you see, then my experiment still works, okay? What I've now shown is that irony and humor comprehension have no factor in sociopathy. So even if your experiment kind of doesn't work, right, you can still use that. It's still valuable, right? Because remember back to our discussion of Karl Popper and falsification in science, right? We're always trying to falsify our hypotheses, okay? So by doing something like this, by having a control group of just normal people or, I guess normal inmates, what that control group sets up is a falsification criteria, okay? And then if there is a big difference between my target group and control group, then that adds, okay, that bolsters my original hypothesis. I might say, okay, well, there's something to it. Maybe irony comprehension and sociopathy are related, okay? Or a lack of irony comprehension and sociopathy. So you see that these control groups are actually very important. And I'm sure that in scientific experiments or papers you're going to do or write, these are probably going to be discussed. They are more important depending on the field, okay? But just to give you an example of this, if I'm writing a paper in the humanities on philosophy or literature or something, I can't really have a control group, okay? The control groups really rest in the realm of the sciences, okay? And it does have to do with this falsification criteria we saw with Karl Popper. Now, in the sections, as you're organizing the paper, right? So you remember we had the title and all that intro stuff, and then you want to list out the sections with subheads, okay? So you might here put introduction, here you might put methods, and then break down in the method section subheadings that list out these three things: the background, experiments and observations, and then analysis. Even if you just use those words, background, experiment, analysis, okay, that will help the reader to understand more clearly what each section is doing. Even though it might be kind of obvious, the little subheadings and subsections do help the reader to more quickly organize the information in their heads. Now, this is all about the organization and the list of the background, experiments, and analysis. This is about you seeking credibility and the replicability and testability of your research, okay? So like I said, very few people are going to read a scientific paper and say, I'm going to retry that. Okay? I am going to take their methods and I am going to do the exact same experiment and see if it works. That's super rare. That's almost never going to happen. Okay, but in terms of the detail that you list out, right? A list of the procedures you took. That shows other researchers and scientists and readers, if they wanted to and they followed this list, right, they should be able to replicate your research project. They should be able to test. So you see, it's about a level of plausibility. Can they plausibly test or replicate your research paper? Okay, so once again, like if I'm doing a survey, I would list out, how I got that survey, the demographics that I sent the survey out to, and then my findings. Because, as I think I've mentioned this in another discussion, but if I am only surveying, let's say, men, okay, if I'm only surveying men who make $100,000 or more a year in their jobs, right? That's leaving out a gigantic swath of the population. Now, if my research project is to study men who make $100,000 or more a year, okay, then that's fine. Then it would make no sense, if I'm surveying women who make $100,000 or more a year, right? If my research project is about men, right, then it would make no sense to survey women, and vice versa. Okay, so in this sense, the survey would have to list out all the details and demographic data that you found or that you used to develop the survey. Okay, just as when I did my experiments, I would have to list out, the methods of writing the narrative, the story that they would have to read for irony comprehension. I would have to list out the rationale behind the questions I'm asking, okay, in order that other people wanting to do a similar experiment can follow that, test it, and then see if they can replicate it, okay? You'll see this replication actually a lot in physics because maybe about 3 or 4 years ago, they were doing experiments with the LIGO, and they were trying to find gravity waves, and they had this result, and this is a very complicated machine. Okay, I won't go into the details on it, largely because I don't understand all the details. But basically, it's trying to find gravity waves. Okay. These would be the actual ripples in space-time that would indicate how gravity works. We're still not quite sure, and this is what's cool, we're still not quite sure how gravity works, right? Gravity works at incredible distances, right? So our little galaxy here, the Milky Way, right, does have a gravitational relationship to other galaxies that might be billions of light years away. Right, so it's very, very, very small, but there is still a gravity. So we still don't really know how gravity works. It's kind of cool. Well, anyway, they were doing research on this, and what they found was that they found a tachyon, or what they thought was a tachyon. And tachyons are hypothetical that travel faster than the speed of light. Okay, travel faster than c, and so. This experiment, they didn't come out and say, oh, we found things that travel faster than the speed of light, because according to physics, nothing can. Okay, you'd have to be. There's nothing that can travel faster than light. Anyway, so other people replicated that experiment, and what they found was that the calibrations, okay, the calibrations of the machine were off. And so, that was a moment of falsification. And so, if they had proven that something can travel faster than the speed of light, it doesn't mean that all of physics is wrong. It just means that, well, we have to revise some of it because it's fallible. Here we had falsification. Okay, so this experiment was proven to have been incorrect. So it was kind of just an interesting example. So sometimes tests are replicated, other times they're not, most often not. But anyway, so that is a discussion of methods. Typically, it's going to focus on these three things: background, experiments, and analysis. Organize them with subheads and titles, okay? And then, watch out for chronological explanations. Watch out for narrating yourself into the story too much. Watch out for self-plagiarism. Don't go into too much detail when you're discussing them. You need detail in there, like I said, so that other people can test and replicate if needed. And that can also help to establish your credibility as a researcher or as a scientist or whatever. And so I hope that helps with methods. We will move on to the next section shortly, once I have some water.